Okay, we're going to start talking about polar coordinates, and polar coordinates are just really another coordinate system. So rectangular coordinates you put on a normal axis, and if I'm doing stuff with rectangular coordinates, I usually have an x and a y, and I'm going so far over on my x and then so far up on my y. So it's basically like driving down a city street. I'm going 4 blocks over, 5 blocks up. Polar coordinates, instead of having that, it has an r and a theta. And the r is telling you how far you're going, and the theta just tells you what direction. So it's more like you're starting in a park, you're pointing someplace, so let's say 45 degrees, and you're walking 6 steps that way. So that is what polar coordinates kind of mean. And we already kind of know how to work with polar coordinates coming from a unit circle. X in a unit circle is just cosine, so if we have a different radius, x is just the radius times cosine. Same for the y. Y in a unit circle is just sine. If we have a different radius, it's y sine theta. So I'm going to go ahead and convert these from polar to rectangular, and I'm going to graph them also. So let's see, if I graph this, pi over 6 is about here. It's in my first quadrant. So it's up there somewhere, and I'm going 3. So it means 3 steps basically. 1, 2, 3. So I'm going to end up there. Okay, if I'm going to turn this into rectangular, then I'm going to use those equations above. So I'm going to move this down a little bit, and I'm going to get x equals 3 times cos pi over 6. Hopefully I know what cos of pi over 6 is by now, or I have my chart. So 3 times square root of 3 over 2. So my x is just going to be 3 square root of 3 over 2. Okay, so let's do my y. My y would be 3 times sine pi over 6. Again, hopefully I have my chart memorized. So y is going to be 3 times pi over 6 is 1/2, so 3 halves. And I want to check, let's see, if I look at this, yeah, 3 square root of 3 over 2, 3 halves should lie in the first quadrant. So it looks like it probably could be that. Let's try a second one. So if I graph this, 2 pi over 3, it's 1 less than 3 pi over 3, which would be pi, so it's somewhere in my second quadrant. That would be where 2 pi over 3 is. But I'm going -2. So when we've been working with unit circle and radians, negative just meant we went backwards, like negative pi over 2 went down. So in this case, same thing. Radius means we're going backwards at negative. So instead of going out here where my 2 pi over 3 is, my 2 pi over 3 would have been this part. So pi over 3 would have been here, 2 pi over 3 over here. I'm going backwards, so I'm going down 1, 2. So I should end up somewhere down here. Okay, so again, let's convert it. So x equals r cos of 2 pi over 3. Oh, sorry, we knew r. R was -2. I don't know why I put r. Okay, so -2. Cos of pi over 3 is 1/2, but 2 pi over 3 is in the second quadrant, so my cos is negative there. So times -1/2. So I get my x to just be 1. My y would be -2 sine of 2 pi over 3. So sine of pi over 3 is square root of 3 over 2. In the second quadrant, sine is still positive, so -2 times square root of 3 over 2. So negative square root of 3. Now let's look at this. If I graph this, that would be a +1 and down square root of 3. So yes, should lie in that fourth quadrant. So I can use these two formulas to convert from polar to rectangular.